Welcome everybody. Thank you for coming. There is one word I need to say in Czech. Are there Czech here? Every talk starts with one word in Czech. You know this word? No? Every single technical talk starts with one word. An old Czech talk I had followed. It is the word takže. So, takže. For the non-Czech speakers, it means so. You cannot start a talk without telling takže. Takže, welcome. It is written. I'm from Belgium. I've spent the last 17 years here. I have a decent Czech when you need to talk about family things and not technical things. It will be in English today. And so I've come here actually in 2001. Guess why? The reason why most foreigners come here? A woman, yikes. I have 5 kids. And I started to work on PostSharp in 2004, actually. So today we are sponsoring the event, and I've seen that a lot of you had ducks. Do you have your ducks? Show them. Maybe I could. Well, one duck here. Now there should be more ducks because we give away so many. Yeah. I will show you why ducks. This is the company mascot. We have big debugging problems. We actually extend the debugger. If you didn't know it was possible, yes, it is possible. You can extend the debugger. And when you extend the debugger, you have big debugging problems. So, what do you do when you cannot debug? It's in production, you log. Today it's about logging. So I started to work on PostSharp in 2004, and in the beginning it was an open source project. It just outgrew my capacity of maintaining that. At some point I was working 3 days a week just on the open source project and not catching up with all the requests and features and implementations I had in mind. So we switched to a commercial company that was in 2009, and now actually, the amazing thing is that when you switch, it's when you create a company, you actually get trusted quite immediately by big names, and it's kind of amazing. Some of these companies came when it was literally just me, or with the first colleague, because these companies, they're actually not called entities. These are individual teams of engineers. And so this is the real customers are not brands; these are small teams. So what is PostSharp? So I will not talk too much about PostSharp today. Basically, we automate the implementation of design patterns, so you don't have to write code. And we are based here. Actually, many people know PostSharp; they don't know we are here. We are 7 actually. We have 6 nationalities currently, and 0 salespeople. Okay, so what about today? Not much about PostSharp, it's about logging. So logging is changing. Really, we are in the period where new features are being developed. The environment in which application is running actually changes. So we will talk about that, a bit of history. How can we log in the cloud? I will take the example of Elasticsearch. Please understand it is just an example, and that there are many solutions. There will be a few words about how we can automate code instrumentation. This is where I will say just a few words about what we are doing in PostSharp. And correlating traces, this is a problem that emerges when you have a distributed application with many web microservices, and you want to trace a distributed request. So we will look at a few practices we can do now. And emerging best practices, a few interesting things I've seen in projects in other communities. Point 6, we will not come to that today. So logging is changing. I wanted to understand the history of logging. And so I went to the Museum of Logging, of course. And the first time, the first time I gave this talk, it was in Montreal in Canada, because this is the home of logging. So But no, seriously. Seriously, do you remember in the 80s, 90s, how did you log? Well, no, in the 80s you had a monitor, but actually the first computers didn't have a display. They have a few lights, but they didn't have a display. So actually the log was actually printing to a paper. And then in DOS, the printer was like a stream that you could address just by printing to LPT1. It was amazingly easy to print at that time. It has never been the best time to print than with MS-DOS, and now it no longer works another way. Anyway, but from that time, like logs are still a bit inspired from that time because they are still a list of lines. But the requirements have changed a lot. So, in the beginning, 10 years ago, most applications were mostly single-threaded, maybe even more, maybe even earlier. Okay, so they were single-threaded, they were monolithic, they were hosted on your own computer, so you could log into the computer, download the log, or do tail, or do VI. They were simple or expensive. What I mean here is that it was more expensive to write code. Therefore, we wrote with simpler applications than now. The applications now have become incredibly complex because it became so easy to do complex things. And an important point, they were monitored by humans. So the consumers of the log file used to be human beings reading that. And you see the logging framework that we have now, they are still influenced by these times. But today, the software is different. It is multi-threaded. It is distributed, running in the cloud, which means that you don't have necessary access to this machine. Software is much more complex because it is so cheaper to build complex software. And logs are being monitored by machines, so big differences. Now, when we think about logging and monitoring, I think we should make the difference between two roles. One role, like the two roles in the DevOps thing. There is a dev role and there is the op role. And you need to look at logging and monitoring actually from these two roles. They have different requirements. So from an operation point of view, what the operation guys want is basically a statistical view of your application and see how many exceptions per second do I have, or how many percent or less or of exceptions do I need. So you need statistical metrics. And this area is called application performance management, APM. I will cite a lot of these tools, but like in my opinion, for instance, Application Insights is an APM system, and you have dozens of APM systems. So just remember, an APM system is there to monitor things, but developers have different set of requirements. So when you are a developer, what you expect from the log is a high level of detail, so you can actually reproduce the problem on your development computer. This is the aim. It's totally different than the operation point of view. So this is where we are going to talk about logging and tracing. And these two roles can actually find their happiness in the same solutions when it is on the cloud, and that's the next thing. So, for instance, as a developer, you would be interested in like detailed application logging, but not in RAM consumption and so on. So you would collect different kind of things. So now, when your application runs in the cloud, there are tools that allow you to get these two streams of information, the developer one and the operation one, and to get that in the consolidated place, so that you can analyze your application from a bird's eye point of view, so statistics, and then you can zoom in and get to the details. There are dozens, like maybe 100, even more, like tools. But if you want to understand what their tools are for, it's good to map the landscape and to know what are the steps. And this is what I would like to do in this slide, is to give you an understanding of what are the steps that are necessary to produce this understanding of logs and metrics. And then we are going to map these steps to specific technologies. One will be the Elasticsearch, well, the Elastic Stack. The other will be Azure. So, but it's important to understand the different steps. So, at the beginning, you have data sources. So, as a developer, you would be interested in the application as a source of logging. But there are logs coming from the operating system. This could be Linux syslog. This could be Windows event log. You have database log, Apache IIS logs. So you have the sources, and these data rely on your local computer that you may not have access to. Then there is one step is data shipping. So this is called, for instance, beats, or well, this is the next slide. But data shipping means we are reading, for instance, the Windows log every minute, and we are shipping that to the log server. So this is the next step. Then you have data ingestion. It means that the data that comes to this level of the pipeline is of different formats, and you need to normalize this format, and then you store it to what I call here the live data store. So live data store is where all these monitored things, so all your performance metrics, Windows logs, Linux logs, database metrics, everything is there, and it is indexed, and it is fast. There is a search API. This store is very expensive. You can pay many euros per month and gigabyte. So this is normally this lives in memory, and this is pretty expensive. Now on the top of that, you have a layer for analysis. You have the dashboard, search UI to search into your logs, and sometimes you have an alerting engine with two kinds of alerts. One is rule-based, that you actually write the rules. When this happens, do that, and the normal is and the other is artificial intelligence tells you something strange is happening. And that's not all. Yeah, from this you can have an incident management system. That means when you see an alert, you create a bug. So some vendors would actually provide this feature. And finally, because this live data store is very expensive, you have the data optimizer that creates the monthly summaries, for instance, drops your detailed data and store it in a cold store that does not cost so much because it is not stored in RAM. So this is a very large pipeline with a lot of components. And if you want to understand anything in the offering of these dozens of companies, you actually need to understand this pipeline from an abstract point of view. Now, how is it in Elastic Stack? So Elastic Stack used to be called ELK because it is, this stack of ELKs. There was Elasticsearch is the live data store. Is basically an index database. You store JSON files, and it gets indexed. Data ingestion is done by Logstash. Data shipping is done by Beats, and dashboards and analysis by Kibana. Then on the top of that, you can install plugins called XPack that will do your analysis. And the first demo I would like to do is to show how you can use, like very quickly and easily, how you can start logging into the Elastic stack. So we will use Serilog, and there is something important about Serilog is that it is structured logging. So remember, the consumer of my logs is no longer a human, but it can be an algorithm, and we may want to bucketize information by parameters. And so Serilog is good because it has been designed for structured logging. So I will take an example that I didn't create myself. So I will just open it from GitHub and show you. And it's an excellent example. The first thing you need to do once you download the project on GitHub, you do docker compose up, and it runs actually it runs the tree stack. So let me go to this. Where should I go? So what is inside this example? I will open Visual Studio Code. And let's look at the compose file. Okay. So it defines one Elasticsearch container. This is the storage, one Logstash process, and one Kibana process. Kibana is the UI, Logstash is the is data injection. And we are going to send things to this port. So how can you use this configuration with Serilog? It's actually very easy. And the nice thing is that Serilog does not need to know that the stack is Elasticsearch. That is remarkable. You do not need an Elasticsearch plugin to Serilog. You just write here. So you define a logger, and you write to the Elasticsearch node. Okay. So we use a durable HTTP target or thing. Durable means that first the items to be logged are going to be stored on disk, and then when the batch completes, it is going to be uploaded. But if the application crashes and restarts, then it is going to, well, the buffer is going to be sent anyway. So now I will start that. This is a very simple program here. It just creates these structured logs, and you will see actually the meaning of having structured logging, because when you do structured logging to a file, it's a bit, well, to a text file, it is a bit useless because you cannot really query it. But actually, this is being uploaded to your. So this is the data being uploaded here. Let me do this. And you see here that you have the object structure of everything. So now you can go to Kibana and do statistics about this. I'm going to do a more complex query with Kibana with the next example, where the statistic will not be just messages, but method failing or not. So you see, it is very easy to use to log to Kibana. If you are using Serilog, you do not need an additional piece of software, and you can use the service as it is being provided, or you configure it like shown here. Okay, now there is another stack available. There are many stacks, but what the equivalent on Azure are not one service, but two services. So from the operational point of view, you need to use Azure Log Analytics. And it has an equivalent to data ingestion also, or to data shipping. So you actually need to install the agent on your virtual machines. So you go, you create an Azure Log Analytics resource, and then you say that you want to install the monitoring to this specific virtual machine that is running on Azure. I think that you can also monitor your local like on-premise machines. But this is not what Microsoft tells that that developers to use, because developers should use application insights. This is for applications. And both are different products, but the good news is that they are integrated. So when you can have both flows of information, you need to import your application insight account into your log analytic account. And that's about all I will say about application insights today. And then you have other open source software. Some are based on Fluentd, so there are like other stacks, but most, so pay attention to that when you will be choosing. You may not have adapters for C#, .NET, and so on. Okay, and then you have a lot, but really a lot of commercial vendors. So when you choose a vendor, I don't have an interest in any of these vendors, but when you choose that, you should pay attention to how they map with this pipeline. So what you will look for, like you will take the operation point of view, like does it collect the data for the systems I use, and then you take the development point of view. You know, does it support all the languages I use? Because if you have microservices, probably you don't have one language in your ecosystem, but you have many languages and many runtime environments. So does the vendor support all of them? You need to look at that from a legal point of view also. If you process data from European countries and you are subject to GDPR, and it is likely that your logs contain customer data. In this case, the law requires you to treat logs with the same precaution as databases, actually, and so that may be a problem. Okay, and pay attention to the financial point of view. This can be very, very expensive. So that was the part for like getting the map of the logging landscape today, and understand it's pretty abstract. And this talk is not about a how-to; it's just to give you an understanding of how things are. Now, shorter. So how can we do automatic code instrumentation? So you know how to do logging. You call logger.write line and so on and so on. But if you have an application with hundreds of methods, you don't want to do that manually. So there are many solutions that allow you to log automatically. So some vendors, one of those is New Relic, for instance, they would provide you automatic instrumentation of your code. The way they are doing that is that they install, so they have an agent running on your machine, and they use a profiling API to inject this code. So this is one possibility. The other possibility is to use tools like PostSharp and to add this logging at build time. This is what I will do in a minute. So that means that you use a tool in your build process to add logging to your code, but without modifying your source code. So you do not need to add logging manually to your complete code. And the third way, you can use the features of your dependency injection framework, for instance, or you can use something like ASP.NET action filters to add logging. So dependency injection frameworks allow you to inject behaviors between the client and the service, and you can add logging here. So I will show how we do that with PostSharp. It's not going to be very detailed, but basically this is how we do that with PostSharp. Okay, we add assembly here to the whole assembly. We say we we want to log everything. Now, this means everything, okay? It means all property getters and setters. So this is not very smart, but it is very exhaustive. And then you create your Serilog logger as usually. You plug it to Logstash here. And then here, this line actually tells PostSharp to log to the logger. And this is actually all we have to do here. Now, if I run this, the build has started. So what happens during the build is that it will add instrumentation to your methods, and you see now a complete log of this very small application that doesn't do anything. And you can see the parameter values and the exception that happens, the return values, and so on. So these are the possibilities. Now the code here is absolutely without any logging. So you have options to add logging to your existing application without any effort, and you have at least 3 families of options. One is provided by the logging vendor or the APM solution. The other is to use a build time tool, and the third one is to use the features of your dependency injection framework, but then you can log only the boundaries of components and not within one component. Okay, so yeah, PostSharp provides more things, like you can trace performance and like it is performant. Yeah. I mean, you can trace execution time also, warnings with threshold and so on. But I would like to go to the next point and to tackle the problem of how do we handle distributed logging. So now we have this application, we added logging there. We know how to add everything to the same database. I've shown it with Elasticsearch. You can do that with application insights too. So now how can we correlate traces? And this is quite new. This is an in-progress work. There is a new standard being defined now at a few, maybe the last 2 years. It is called OpenTracing, and it defines concepts. And it defines an API. So one concept it defined is a span. A span is a group of lines of trace. References between spans, it means that this span is created by this one. So a reference can be parent-child, for instance. Causality. It defines tags. So tags, these are like properties of a specific span, and it defines baggage, which are the like sticky properties that are propagated along the calls, the remote call through a web API, for instance. So this is a standard, and they have a flagship implementation. It is called Jaeger, and there are actually several products that implement that. But the thing is not in .NET. So OpenTracing is a good initiative. There is not really a .NET implementation, but I will come to that in a minute. And Jaeger is able to visualize your distributed call like this. You'll do nice visualizations. Okay, but now what is in .NET? Well, in .NET, you maybe all know system.trace, system diagnostic trace, right? This was the first tracing API we got. Then we got trace sources. Trace sources, so it added this trace switch. And then we had this correlation manager. Do you remember using that? I've not seen anybody ever using the correlation manager, actually. No user of the correlation manager. So what the correlation manager did is to let you give like it implemented this is a it was implemented in WCF. So inside WCF, you could actually say this operation is the child of another operation. We had event source and the system.diagnostics.eventing namespace. It added semantic events like Serilog a bit later, but that means not only text, but the parameters were treated like values. I just realized I forgot the demo. That's why I'm going so fast now. And this used the correlation manager. Then we got iLogger from Microsoft. This was in ESP.NET Core. The idea of iLogger was to move from like static classes to classes that could be injected through dependency injection. And now we have another class, and it is diagnostic source. So did anybody know this diagnostic source before? I was quite surprised. Yeah, one here, maybe 2 or 3. So now we have diagnostic source, and the thing that the new thing with diagnostic source is that you have a class named activity. And actually, this is an implementation of the OpenTracing standard. But it is done by Microsoft, so they do not say it is an implementation of the standard. But basically, it really follows the same philosophy. I'm being a bit unfair because if you go to the documentation of diagnostic source, they cite OpenTracing as a source of inspiration. So they're very clear about that. So they have this concept of activity. And now it is in .NET Framework. It is also in .NET Core. So an activity is something that starts and ends. It can have children activity. You can have tags and baggage. So the baggage is something that is sticky and that propagates through method calls, remote calls. The thing is that now there is no support for this activity. There is almost no library that uses this new diagnostic framework. So you could not say, great, I'm going to use activity because this is the way to go, because you will not get support for that in, say, Serilog, nlog, and so on. So these are new concepts. And so maybe you can understand the name of the talk here is that logging is hot. But when it's hot, you cannot even touch that because actually this is a bit unusable. So what is activity used for? Really, it is used by application insights. So if you use application insights, then you can use this new API. So here I would say for application developers, it's still a bit unusable, and there is you need to find another way. So Microsoft also defined this protocol, HTTP correlation protocol. It is used by application insight to correlate. So the application insight client uses this protocol to talk with the application insight agent that runs inside your application. And there is a very special trick. If you define a diagnostic listener of a special listener, then headers are going to be added to your to the request of your HTTP client. Very strange side effect. So I believe this is not fully usable now. There is not the tooling done. So what can we do? What can you do now with to correlate request? I will take the example of Serilog again. So the first thing we need to do is to define, so on the caller side, we need to define a property operation ID. The name is not important here, but it's actually the same used by application insight. So we add an operation ID. And the way to do that with Serilog is that you need this thing here that first you need to say that you are going to use this concept of log context. So a log context, this is an async local context. So if you have async code, it is going to follow your async methods. And then inside your code, you are going to push this property. And now so on your client side, the code is going to well, your log events are going to have this property. I will show this in a moment. So this is one part. Then you need to push this property from the client to the server to add this request ID. So according to the HTTP correlation protocol, this is the request ID. So the name of this header is request ID. So there are many strategies that you can use to do that. One is to go to every use of the HTTP client and add this property. You can wrap the HTTP client into another class. You can use the special hack with activity and HTTP handler diagnostic listener. You can use PostSharp to intercept calls to HTTP client, or that is the best way, and it is implemented in .NET Core 2.1. You can implement your own HTTP client factories. So when you get the HTTP client from the factory, you can add this header. Okay, so now the status is that on the client side, you added the operation ID to the log, so this is done. You added that to the header, and now on the server side, you will need to read the header and push the header to your logging system. And so the best way is to use an action filter, an action filter in ASP.NET MVC, and just to read it and to define an operation with log context. Okay, very abstract. Now I'm going to show that in practice. So this code here is going. So this example is extremely simple. It just creates a get, post, put request on a trivial example. So the way I implemented correlation here, well, because I'm a PostSharp fan, so I did that with PostSharp. That's really not the important point. The important point is here. So what we are doing here is that we are adding some code to get, delete, post, push, patch, like anything async of the HTTP client. So what's important here is what is inside. So we defined an operation ID here, and we take the HTTP client. Then we push the property to the logging context. This is the Serilog code. That line is not important, but so this is basically the two things you need to do. Is to add your default header and to push the property. So you need to do this, and then you can call your I'm lost in my thoughts. Well, no, your method. So you invoke what you actually intercepted. So that means, but normally you would create this property here. You would create it upstream. Here it was really downstream, but you would create it. Say it would be maybe better to create it here when I process an item, and I want a specific log for processing this item. So the way I did that is to add it here. That means to get async. Now to the where does it is it on the server side? It is actually very easy and very clean, because here you have the right abstraction done by the framework, by the ASP.NET MVC framework, and you create an action filter. You read your request, and you push the property. And within that context, you proceed with the invocation of the next thing in the pipeline, which is probably calling your API method. Okay, 2 steps, client side, server side. Questions about that? No question about that. So let's run that, and I will go back to the demo I forgot. Normally I do this talk a bit longer, so I was in a rush, and then being in a rush, I forgot to do an important thing. So sorry about that. So I run that again. Now I'm going to, here you can see this is the code on the server side. You can see that I also added logging here, but on the console output, I don't have this operation ID. So let's see how this works. I will do first the first demo, and because it shows you why it is important to have structure logging for machine processing. So before I will create analyze this log, create a visualization, and it's easier to start with a data table here. I would like to know which methods create the most warnings or exceptions. So first I will bucketize by type, then I will bucketize by method, and then maybe I could bucketize by arguments. That's an interesting case when you are analyzing failures, to be able to do statistics on your code performance. So here I'm in Kibana, which is the UI of the Elastic stack. So I'm going to aggregate by source, which is the type. Okay. Now you see that I have these, so messages come from these types. Now I'm going to aggregate by method name. So I need to add a term. I need to add, this is the member name. How do I click this? No. Here, okay. So now I have the method name. Here is the number of messages. I need to filter the messages, and I don't remember what is the name of this property. This is property dot. Where is that? I want to know what is the verbosity. Is it in level? I will see it here. So I will create another bucket here. Filter by terms. Which term? Level. Yeah, the level keyword. Okay, now I see, okay, here I have warnings. So actually I'm just interested by warning, so I can say where level is warning. So I can do that. And now I may be interested, like now suppose you have thousands of errors and you need to analyze a parameter. So you could add another level of bucket and say, so I filter by term, and here I'm going to filter by the first argument. So now we have the argument framework of the argument value here. And now you know that you need to actually look at method calls that have a value 1 or 3. So what I'm showing here is the reason why we say now that consumers of logs are machines. Because with this kind of analysis, you can actually like analyze your code statistically. and find the interesting pieces of information. And so this is an important trend to have logs that can be parsed, not only parsed, but that are optimized for being processed by such machines. So let's now do the other demo and see how do we correlate requests. And for this, I'm just going to show in this view. And I want to add the field properties.application. Okay, so here I have the example. I have the client. Okay, I have both. I will add this is properties.operation and properties.parent_operation ID. Okay, so now I have these operations here, and I can start to filter. I will take this one. And now I can have a view of these two operations. So I need to filter on properties. Operation ID is this, and properties parent operation ID equals this thing. Okay, and now I have exactly what I wanted. I have two services, and so I have the log so coming from two different services that I can now see. You see another set of problems happening, and it is the time and sorting the records and so on. So I'm able to do it from like to do the complete use case. But you see, using this tool, this is still hard. You still need another kind of tool. And currently, there are good tools in some other ecosystems like Jagger, but for .NET, I couldn't get it to work with application inside. So what do you do with application inside? You actually do pretty much the same, but you actually map parent ID to a well-known property of notify property change, but not enough time for the rest. So currenting traces, this is it. Okay, so interesting ideas I've seen. So use smart operation IDs. So GUID are not smart operation IDs. So activity, the activity class creates hierarchical IDs. It's a wonderful idea because you can actually filter and say, give me all operations whose IDs start with this. Okay? So if you follow this kind of pattern, then you can actually, so you don't need to do the creation of each call. You can just do start with. So this is a great idea coming from the diagnostic source team. Made that sortable because timestamps are not precise enough. So this is a good idea implemented by the activity. And another trend interesting to follow is, I would call that semantics first tracing. So now the way we've been doing tracing previously was to create strings with parameters and like formatting string with parameters. And the new way to do that is to have message names with parameters. Like so for instance, so you need a message name that is, for instance, get account, but not get account 152. You would have so 152 would be the value of a parameter named account ID. So you have to have in mind that your logs will be processed by the by a tool like Elasticsearch or Application Insight can do the same kind of analytics. So that's important, but the current tools in .NET are not ready for that unless you use them a bit smartly and do the message parsable and so on. So you need to hack to do that. And the last good idea, I will just name that, but nobody needs a million of traces per second. So a good idea coming from Google is that you would log randomly a sample of the request. And the way to do that with the Seri log, for instance, is that instead of having a static logger, you would have an async local logger. When you start your request, you decide if you want to trace it or not, based on the requester IP or based on whatever you want randomly. Okay, so that's a good trick to use. It doesn't cost you much to have an async local instead of a static. So a good trick that has not been implemented yet. And now summary. Well, logging is changing. And this talk is really about a landscape that is changing. The tooling in .NET is not mature, and so there is a frustrating part in this talk. And I was frustrated actually, like writing that. Is that what I don't have any like how to give to people, and so, but this is the status of logging now. There are new standards, not yet mature, but you can do choices now about how you will use, for instance, Serilog. You can use Serilog now in a way that is a bit more ready for structured logging using Elasticsearch, using application insight, and so on. And I've shown a few things, and you can do automatic instrumentation too. So that's all I have now. Thank you. Thank you. Are there questions before we leave? I don't see questions. Okay, so I think we still have 1 or 2 pies to give away. If you turn the wheel at the booth. Actually, yesterday we gave away too much, so we stopped, and now we realize that everybody came the first day. So there are still 2 pies, and the conditions are easier. Like I think now the chance is 1 on 10 or 1 on 8, so you should give it a try. Thank you very much.